All right, technique number 3. The essence of technique number 3 is we need to shift reference frames. This would what we call the lab frame or the problem frame. So this is how fast they're going just based upon the problem. You can assume that you're standing on the side, you're looking at these two things coming at each other. But there's nothing special about the lab frame other than that's what the problem's expressed in and that's what the answer needs to be in. But I could also do it from the 5 kilograms point of view. I could do it from the 8 kilograms point of view. I could do it from some other point of view. And so that is what we're trying to do. We want to figure out what reference frame does it need to be in order to make the math as simple as possible. So just from a reference frame point of view, so it all depends on the speed of the observer. So the velocity of the observer, the velocity of the 5 kilogram mass, this is in meters per second, this is in meters per second, and the velocity of the 8 kilogram in meters per second. So just sort of set this up, I'm going to do sort of a trial and error thing. I'm not looking for, I'm not going to do our final solution this way. This is trying to illustrate what I mean by this. So if the observer is just standing on the side, like right now, this is going at 3 meters per second, this one's going at negative 4 meters per second. If I do it from the 5 kilograms point of view, actually let's take it one step further. So the momentum of 5 is 15. This is in kilogram meters per second. And the momentum of the 8 is negative 32 in kilogram meters per second. And the total momentum, initial, and actually, get rid of that, in kilogram meters per second is negative 17. All right, this is stuff that we've already done. We've done this several times. Now, if the observer is going at 1 meter, let's take it 3 meters per second. So if the observer is going at 3 meters per second, in other words, he is keeping pace with this right here, then this is going 0 meters per second. This one, the observer, I'm now approaching this one faster, and this one's going negative 7 meters per second. The initial momentum of this in this reference frame is 0, because 0 times 5. And then negative 7 times 8 is negative 56. The total is negative 56. Now, if from his point of view, so now in this point, as the observer, I'm traveling along with this. This one looks like it's going at me faster. This one is, so I'm going at now negative 4 meters per second. So it looks like it's at rest relative to me because I'm moving right along with it. This one's now coming a lot faster at me. The initial momentum here is 5 times 7 or 35. This one would be 0 and 35. So what I'm trying to do, in order to make it easier, I want to find the 0 momentum frame. I wanted to figure out how fast do I need to go so I get 0 over here. That is the key to this technique. And we're going to get the solution, then I'm going to point out that we've actually already solved it. So what I want to do is I'm going to do it the long way, and then I'll tell you the shortcut. So let's just pick one more just for the sake of it. Suppose I'm going at 1 meter per second. So this one's still going faster than I am, but only by 2 meters per second. This one's now coming at me at negative 5 meters per second. Notice that's what's happening here is that I'm subtracting whatever this is right here, I'm subtracting it from those. So 3 minus 1 is 2, negative 4 minus 1 is negative 5. My P5 over here, so it's 2 times 5 or 10. This is negative 40, and so this becomes negative 30. Yeah. So now the technique to actually find out how fast does this need to go in order to be going at the proper, to have 0 momentum. Since how fast the velocity of the objects depends upon the speed of the observer or velocity of the observer, what I want is my initial momentum to equal 0. And that's going to be 5 times how fast its velocity minus the velocity of the observer, which I'm just labeled as v, plus 8 times -4 minus v. This v right here is the velocity of the observer. So this becomes 15 minus 5v is equal, not equal to, minus 32 minus 8v. So 15 and 32, so that is 47 minus 13v equals 0. And so v is equal to 47/13. I feel like you got a sign somewhere off. Oh, yes, I did. 15 minus 32 is -17, and so v is -17/13, or -1 point. I know we've done it already, but 17/13. 1.3077 meters per second. That is the speed of the observer in the zero momentum frame. That is what I'm subtracting from each of these. So recognize that is also the speed, or the velocity, of the objects in the perfectly inelastic collision. That is not just coincidence. That is the way it's going to be. So if I actually solve the perfectly inelastic collision first, then I'd already have this. I don't need to do any of this math right here. So let us now do the problem. So we start out in the problem frame. I'll use this space over here. So in the problem frame, in other words, from the point of view of the problem, my velocities of the 5 and the velocity of the 8. The velocity of the 5 is 3 meters per second. The velocity of the 8 is -4 meters per second. I'm now going to shift to the zero momentum frame. So shift. So I'm going to subtract -1.3077 and subtract negative, because I'm subtracting whatever that is. See, I'm subtracting whatever that is. Subtracting -1.3077. And so I have, so in the zero momentum frame, this is going 1.6923 meters per second. And this one is going, oh, oops. It would help if I actually did the math correctly. I'm subtracting a negative, so I add, so this is 4.3077, and this becomes, so we got that for -2.6923. All right, so this is how fast they're going before the collision in the zero momentum frame. Then there's the collision. In the collision, this is where the math is the simplest. I want the kinetic energy to be the same. I want the momentum to also stay the same. Well, my momentum is 0. Think about the equation that it's mass times velocity of one plus mass times velocity of the other. If all I do is switch the signs, in other words, just have them go back in the opposite directions, all I've done is, it'd be 5 times 4.3077 plus 8 times -2.6923. That should add up to 0. If all I do is change the signs here, make that negative and make that positive, it's still 0. All I've done is just multiply everything by -1. And 0 times -1 is still 0. And so, and the kinetic energy cares about speed, it doesn't care about direction. So what I'm going to do is, after the collision, I'm still in the zero momentum frame. I'm just going to change the signs here. -4.3077. And this is positive 2.6923. Convince yourself, go through the math. Actually, let's go through the math right now. The total momentum here, so it's 5 times that. So 4.3077, enter. 5 times. So my momentums, and let's do it in a different color just to differentiate. This is 21.5385 Newton seconds. And this one, 8 enter, 2.6923 negative. Negative 21.5385. Technically it's a 4, I've got a rounding error there, but hopefully you can, if we kept the decimals all out, we'd be good, but slightly off. But this adds up close enough to 0. Over here, if I multiply it out, this one is now negative 21.53, just 0.54, and this one is positive 21.54. All I did was just change the signs of their momentums. Now, we can't leave the answer there. The answer needs to be in the same reference frame as the initial problem. And so what I need to do is I need to shift back. So before I subtracted negative 1.3077, now I'm going to add plus negative 1.3077 plus negative 1.3077. And then I'm back to the problem frame. And so 4.3077 negative, enter, 1.3077 minus, and I get negative 5.615, 4, and over here, 2.6923, 1.3077 minus, and I get 1.3846. And those should be the same answers as we had before. This has the huge advantage of I'm not dealing with systems of equations. All I have to, I have to figure out what my initial what the speed of the observer is, velocity of the observer is, so I can do my shifts. But the math is incredibly simple once you have that. The disadvantage is it's a little bit more abstract in concept. And so given the 3 techniques, you need to figure out which one is the one that really suits you best. So what I'm going to do right now is, no, actually I will make it a separate video. So I'm going to pose a problem and have you solve it various ways. All right, and